Welcome everyone. This session is how to secure your containerized and Kubernetes-based workloads. My name is Ray Maxwell. I'm Director of Solutions Engineering at Polyverse. We provide security for Linux on all aspects of memory-based attacks protection. And with me is Alex Lawrence. Alex.
Hi, this is Alexander Lawrence. I am a Principal Solutions Engineer here over at Sysdig, and Sysdig is all about the kernel and grabbing system calls and being able to kind of know what's happening in your environment in context of everything going on.
Great. Well, let's just jump right in here. Can you guess what these numbers relate to? 77 is the percentage of successful attacks that are fileless. So these are attacks that don't require drop any files onto the file system of the victim's computer. It's all run in memory, and it takes over the processing of an existing application that's been exploited. 102 is the average number of days that it takes to patch a system. So from the day that a vulnerability is discovered, which we'll call a zero-day attack, till the time that it takes to patch it, it's going to be 102 days. I'll dive into that a little bit more. 20 minutes is how long it takes for an attacker to exploit an unpatched system. So when you consider the difference between 20 days and 20 minutes and 102 days, clearly the economies are in the favor of the attacker for exploiting as many systems as they can possibly. So just to give you some context, sometimes these vulnerabilities are born 270 days before they're actually discovered. For example, there are cases where they've been there for decades and nobody's actually discovered them. Or maybe they've discovered them, but nobody has made them public. And so from the time that they're actually discovered to the time they're actually disclosed to the public, it's about 70 days until the patch is released. And then an additional, altogether 102 days before then they have to be tested and then finally deployed. So that really opens up a window of opportunity for hackers to take advantage of to exploit your systems in that interim time. So even after you've patched them, you really don't know whether your system it has not been compromised. And unfortunately, that is currently the state of affairs in our industry, is that for zero-day attacks, the solution is to patch as quickly as possible. So there's constantly firefighting where organizations are having to patch is on the go. So this quote really kind of sums it quite well. That the FBI director said in 2012, there are only two types of companies: those that have been hacked and those that will be. So how does polymorphing help with this situation? Well, what we do is we create unique versions of Linux. So that way, your Linux system and Alex's Linux system and mine are no longer all the same. They're not clones of each other, which is currently what happens today. But with polymorphing, we can make each one of these instances unique. And the way we do that is we take the source code, the dependent libraries that it requires to build those libraries, and we compile and scramble it at the same time and generate the Linux packages. We generate over 70,000 Linux packages that are supported across the different distributions. And there is no change to performance, processes, or interoperability because this is done at compile time. There is no runtime that impacts the performance of your system. So how do we actually do that? Well, there are two things that we perform. One is we load the libraries and the functions that contained in those libraries at different address locations on the stack. So on a vanilla system, the library would be loaded at a specific address on the stack. And so a hacker would be able to determine what that address is ahead of time in order to exploit that particular vulnerability. In our case, we're changing dynamically. We change the address where it gets loaded. And then the other aspect that we do is that we change the assembly instruction sets to be equivalent, but we scramble them so that they're different. So for example, in this particular function called victim function, we've actually compiled this into 3 different unique equivalent assembly instruction sets. And so that's how we create binary diversity. I'm going to pass it on to Alex, who's going to cover about Sysdig.
Yeah, so Sysdig's really about how to secure your environment from conception all the way through an attack itself. So we look at things like the build environment, so scanning images, doing compliance validation, looking across that entire stack for what the applications specifically are trying to do, things like that. We also do that at runtime, being able to look at actual live activity on your infrastructure, seeing specifically what was going on during a given time, if you have events happening, things that transpired, shells being opened up, basically giving you really deep visibility into that runtime aspect of your environment. And of course, coupled with that, being able to respond as appropriately. So being able to hook with things like Jira Service Desk or other like SME workflows that you have built out in your environment. And then just doing generic auditing and alerting and things like that as well. So that's, let's say there is an attack, there is something that does happen in your environment. You're able to not only figure out what image was compromised or what exploit was used based off of CVE, you can tie that back to activity that happened on that, that host or container itself, and be able to get a forensics record of everything that happened during that exploit on that given container or given host and dump that into your workflow. To do that, we do it a couple different ways. We have a number of tools that we leverage. So on the image analysis side, we use things like Encore Engine from the metrics perspective, so getting data about things happening across the hosts. That's really around Prometheus. Being able to really dive deep into the analytics of what's happening on a system in terms of security posture. That's with a tool called Falco. It's one that we wrote and gave away to the CNCF that's used really heavily in Kubernetes runtime detection. And then to be able to instrument and get all of that data, we use an open source tool called Sysdig that we also wrote, not to be confused with the company Sysdig itself, that allows us to be able to get really deep into the host kernel and gather system calls and things that are going on within the host itself. We do that a little bit differently. We're able to actually deploy multiple different ways. That could be as a daemon set for Kubernetes, that could be as a Docker container, that could be as a raw process on a Linux host. Ultimately, they all do the same thing, where they instrument the host kernel with an eBPF application to be able to gather telemetry from the kernel and grab all the system calls that traverse it, regardless of where they came from. So if it was from something like a Docker container or that raw process, if it was something from like a cryo runtime, if it were from Kubernetes itself, we can gather all of those system calls that are hitting the host kernel itself and get into what's going on. So let's say you've got a Apache server that opens up the HTML directory, right? So that might look something like process ID does fd.open against var dub. That's happening in a container on a host somewhere. That's not really effective to know in and of itself. But you add that with context from the hypervisor, from the Docker runtime or the cryo runtime, from context of the host itself, and then being able to kind of link all that together. And we can actually help you visualize all of this data service to service, not just application to, not just host to host or container to container. That allows you to get really deep into the way an application was leveraged or exploited or used, and get the context around all of the events that occurred therein. So yeah, I mean, with that, we'll pass it back over to Polyverse to do a demo of how they can protect the systems.
Thanks, Alex. So I'm going to show you a demo of how I can exploit a buffer overflow. All right, so for this demo, what I have is 3 terminals. On the left-hand side is the terminal to the victim server called server, which I'm connected to already, and I'm on the root /root folder. On the top right-hand corner, I have the attacker server, and here I have a script that will generate my payload. This is going to be the buffer overflow exploitation string that it gets generated. And at the bottom right, I have my command and control server, which I have here running netcat, listening on port 5555. And I've already initiated an ls command so that when the attack is performed and is successful, I'll be able to see the contents of the file system on the victim server, which is on the left-hand side. So let's go ahead and perform the attack using SSH. I'm going to SSH as root to the victim server called server. And since I don't know what the password is, I am going to paste in this buffer overflow string that's going to exploit it. And let's do it one more time for good measure here. And there it is. You can see that I'm able to see the contents of the file system. I'm going to go and cd to the root folder, and I'll be able to see the content there. Now, just for funs and giggle, I am going to create a file here called you have been hacked. Call it victim.txt. Let's go back to the victim server here and actually see if we have that file. And sure enough, you can see the file is right there, and there's the contents of the file. So you can see from the command and control center that I have full control over the victim server. Now what I'm going to do is I'm going to polymorph this system, and I am going to redirect the package manager to polyverse.io instead of the default repo. So what I've done here is a curl command that's actually going to pass in also the license key, which is the auth key over here. Now, feel free to try playing with it, but it'll expire after this demo is done, of course. And now you can see that I have the installation successful. Polyverse is now your preferred repo. And so the next step I'm going to do is yum update -y. So I'm going to update the mirrors. And once this is done, I'm just going to go and update the glibc library for the sake of this demo, because updating all 70,000 packages would take quite some time. So for the purpose of this demo, I'm only going to update that particular library that has the buffer overflow into a scrambled version. Now keep in mind that scrambled version still has the buffer overflow vulnerability, but you'll see as when I go and attack it that the attack no longer works. So on my CNC server here, I'm going to go and restart my netcat command on port 55, so that it's ready to go. And I'm going to type my ls command so that I can see whether I'm able to actually get full access to the file system on the victim server. All right, so just for brevity of time, I paused the video just a little bit while this process was going. But now I'm ready to go and update and reinstall the glibc library that has the buffer overflow exploit that is used by SSH. So now it's going in and downloading it, and done, completed. So I'm ready to perform this exploit again and see if this works. So I'm going to SSH as root again, and I'm going to pass in the same buffer overflow string. Press enter. Now you see the authentication fails, but notice over here on my command and control center that the command no longer works. I have no access. I'm not getting any response back. So this shows that even though the buffer overflow is still in the library, by using a polymorphic version, a scrambled version of that library, this attack no longer works. I'm going to pass control over to Alex, who's going to show the Sysdig side of things.
Thanks. So what I'd like to be able to show you all is kind of what just happened, but from the Sysdig perspective. So we'll go through the interface here in Sysdig, and you can see here we have a running list of commands and running things that we detected happening inside of those various containers. So over here you can see that we have the server, we've got the CNC server, we have the attacker, and you can see there's a bunch of activity we've picked up going on inside of those various containers. So if you go highlight one of these here, like this one, it's called port open for listening. So if I go ahead and highlight this guy, I can see on 0005555 that we did have a open connection built. So I can actually see not only the open port and the local IP address that it came from, in this case just localhost, I also can see the process that spawned that connection. So I can see the netcat-L5555. Along with that, I can see things like network tools running. So this is going to pick up that same netcat command. So we can see there was a netcat that was definitely issued there. I can even come in some deeper stuff here, or if I go looking into this event series, I can see a couple of things went on. We had some suspicious file system changes, and we had terminal in container opened up. If I highlight this terminal in container, I can actually see again host IP server, container that was impacted, container ID, and I can see details about that down here. So the user root on CNC server opened up a shell. I can actually go in here to view commands, and I can get into my command audit, and I can start tracking all the various things happening, right? So again, bash was opened up. I can see netcat being open for listening. I can even go in here and look at my entire infrastructure and get a view over the last, say, like 10 minutes. And I can see all the interactive commands that were running across those boxes. So we can see a number of things happening that are system related, but we can also see those same things happening that were malicious. So things like the network or netcat being executed. I can see shells being spawned. I can see other things being deleted or accessed. So this is the yum update that was going on over there on the other box as well. And I can see all sorts of stuff happening across those various hosts. If I go back over to my policy events view here, I can start zooming in on other aspects too. So if I come over to those suspicious file system changes, I can go down there. I can see this file system change here. If I go highlight this top one, this was on the server itself. I can actually see that there were things that were modified down here. This was actually, looks like it was yum. Let's go back to one a little bit older. And we can see a number of other things happening. Again, I'm getting some noise here from yum doing an update. Let's go back to another policy event here. Let's go to our last 30 minutes. And we'll come down here to an earlier test. And if we come into this grouping here, I believe, we should be able to zoom into the file system changes here. And we can actually see this is the one where we had bash opened up. So we can see that there's a shell open for writing from the attacker side. So basically the attacker spawned that shell against the server itself, and we can then see those connections happening as well. So basically what's going on here is we're doing an interrogation of all of the various system calls that are happening across these Docker containers, and then looking for matching rules that we have in our library and being able to detect those various activities over the course of time. In this case, you can see that these are all centered around terminals being opened up, files being written or accessed, and things being changed across those file systems. And so if I go down here to this one, we can actually see the Polyverse repo being installed. So we can actually see various things being modified across those systems as well, even into the package repositories themselves. If I go look at the policies here in the rules library, you can see all these different activity things that we can detect. So these are all various rules that we've written to look for configuration changes, to look for changes in the system itself. So things like the etc directory. We can look for stuff happening below binary directories. We can get into details about shells themselves, user activity, even up into the Kubernetes stack to look for things like deployments, pods, cluster roles, bindings, things like that being created. So we're able to leverage this runtime detection engine to be able to do all sorts of interesting analysis across those hosts and be able to detect different things going on across that environment as you're seeing attacks and things like that. So with that in mind, I'm going to flip back over here to the PowerPoint for some closing thoughts.
Thank you, Alex. This is really quite impressive. Polyverse is really excited to be partnering with Sysdig on this integration to provide not only protection of your system, but also the monitoring aspects of it. And with polymorphing, just to highlight a few key features, it provides a full stack protection from the kernel all the way to the middleware. It's easy to install. It's a one-time configuration where you repoint your package manager to Polyverse, and then you can update your binaries, your packages, as many times as you want, downloading a new scramble every time. It's distributed through your standard package manager, so that means that there is no change from a user perspective, customer engineering process or performance. And because it's at compile time, there's no performance impact or interoperability issues. You can still use the same debuggers to debug your application. It's basically a fire and forget management system that we have. With Polyverse, you can now protect your system before the attacks, before they actually start. And with Sysdig, Alex?
Yeah, and so where Sysdig comes into play here is that when you do have that rare occasion where something like some exploit is still found, even though you're running something like Polyverse, we're able to detect when those activities do occur, how they got in, users that were accessing various content, what files were modified, everything like that. Today, we really focused heavily on the Falco side of things, so the runtime detection, the runtime aspect of this world. We also, of course, cover those areas around that as well, but for sake of time, we didn't want to dive too deep into that and really focused heavily on where we really complement someone like Polyverse being able to help do this security for kind of the modern age. If you guys have any questions, of course, we're always happy to field them and be able to dive deeper into various topics and various things that we're doing in both companies. So feel free to reach out to us, and thanks for listening.
Thank you.